Today I will discuss maximum likelihood estimation of logistic regression. Suppose we have k explanatory variable x1, x2, xk and y is our response variable. Then probability yi equal to 1. This yi correspond to ith response, and each response take two values, either 1 or 0. So probability of taking yi equal to 1 is equal to pi I, and probability yi equal to 0 is equal to 1 minus pi I. And suppose we have n independent observation, then likelihood estimator, likelihood function of beta curve given y1, y2, yn, where beta curve is equal to beta naught, this is correspond to intercept term, beta 1, beta k prime is equal to product of I from 1 to n pi I to the power yi 1 minus pi I to the power 1 minus yi. Now suppose this is equal to capital L C. Now log likelihood of beta curve, we denote it by small l beta curve equal to sum over I from 1 to n yi log pi I plus I from 1 to n 1 minus yi log 1 minus pi I. We know pi I equal to exp sum over exp sum over I from 0 to k xi x sum over I from j from 0 to k xji beta j by exp by 1 plus exp sum over j from 0 to k xji beta j, where x naught I equal to 1 for all I from 1 to n. Now partial derivative L beta curve with respect to beta j equal to partial derivative of L beta curve with respect to pi I into partial derivative of pi I with respect to beta j. This is a chain rule, and we see that partial derivative of pi I with respect to beta j is nothing but a pi I 1 minus pi I xji. Now partial derivative of L beta curve pi I is equal to sum over I from 1 to n yi by pi I minus sum over I from 1 to n 1 minus yi by 1 minus pi I. So partial derivative L beta curve with respect to beta j is equal to yi into 1 minus pi I xij minus 1 minus yi pi I into xji. This is xji. So therefore partial derivative dl beta curve with respect to beta j is equal to sum over I from 1 to n yi minus pi I xj I. Now we can write this as x x j1 x j2 x j n y1 pi 1 y2 pi 2 yn pi n. So this is denoted by xj curl prime, and this is y curl minus pi curl. So and this is true for j from 0 to k, where x naught curl equal to 1 curl, that is a vector whose all elements 1. dl beta curl with respect to d beta j curl. Now dl beta curl with respect to beta curl is equal to dl beta curl with respect to beta naught d partial derivative dl beta curl with respect to beta k curl prime. So if we replace this, then x naught curl prime, x1 curl prime, xk curl prime, y curl minus mu curl. So therefore I denote this by a matrix capital X prime, where x is equal to 1 curl. First column is a vector whose all elements 1. Second column is a n values corresponding first explanatory variable. This is for second explanatory variable, and this is for kth explanatory variable. So, and I already mentioned I denote x naught curl by 1 curl, so I write x naught curl instead of 1 curl. So the order of x is n cross k plus 1. So this should be x prime y curl minus pi curl, where pi curl equal to pi 1, pi 2, pi n prime. So, partial derivative of L beta curl with respect to beta curl is equal to x prime y curl minus pi curl. Then I already got this expression, partial derivative of L beta curl with respect to beta j is equal to sum over I from 1 to n x ji yi minus pi I. Then del square L beta curl with respect to beta j beta k is equal to minus I from 1 to n xji del pi I with respect to beta k into with respect to beta k. So we know this is pi I into 1 minus pi I x ki, then this is equal to minus sum over 1 to n x ji x ki pi I 1 minus pi I. So we can write this as minus x j curl prime w x k curl, where this w equal to diagonal matrix whose diagonal elements are pi 1 1 minus pi 1 pi n 1 minus pi n. So if you compute for all jk, then you get a matrix of order Now this equal to 0 का. This is a system of k plus 1 nonlinear equation with k plus 1 unknown beta j's. But solving a system of this nonlinear equation is not easy. The solution cannot be derived algebraically as it can in the case of linear equation. The solution must be numerically estimated using the iteration procedure. Most popular method is Newton-Raphson method. So this is our k plus 1 system of nonlinear equations involving k plus 1 unknown beta j's and this is called Hessian matrix. And this equal to x prime w x. I denote it by 2. So here we use Newton-Raphson method. According to Newton-Raphson method, say this is the equation. So according to Newton-Raphson method, first we begin with an initial guess. Say it is x naught. This is the initial guess. And assume first order derivative of fx exists at x is equal to x naught. Then consider first degree Taylor polynomial This is the first degree Taylor polynomial Just consider first degree term. So this is fx equal to this, approximately this, and this should be 0. And assume that if f dash x exists at x naught, then the first approximation, we denote it x prefix 1 within bracket is equal to x naught minus fx by fx naught by f dash x naught. And for lth step, this should be xl minus 1 if xl minus 1 f dash xl minus 1. So x1 is a first approximation. Similarly, using x1 we get second approximation x2, and so on. We proceed or stop the method until xl approximately equal to xl minus 1 up to desired degree of accuracy. This is the procedure of Newton-Raphson method. So here I use Newton-Raphson method. So the first guess is beta curl not. This is the first guess or initial guess. Now just I write the method here. So x equal to x naught or x1, the first approximation, equal to x naught minus fx naught by f dash x naught. So this is our fx. So this should be 0 curl. So first approximation beta 1 curl is equal to beta naught curl minus fx naught is x prime y curl minus beta curl. So please, this is a matrix and this is a scalar, so please keep this in mind, the order of a matrix. So the order of this is k plus 1 cross 1, and order of this is k plus 1 cross k plus 1. So this is a k plus 1 cross k plus 1 matrix. The order of this matrix is k plus 1 cross k plus 1. So fx naught is x prime y curl minus pi curl, and this is, since it is a matrix, so this is nothing but a f dash x. This is f dash x because this is our fx, so it is a f dash x, but this is a matrix, so it should be minus x prime w x inverse, because this is a full rank matrix, so it is invertible. So beta naught curl plus x prime w x inverse x prime y curl pi curl. So in this way we get the first approximation of beta curl. So using beta curl 1, the first approximation, then we get second approximation using first approximation, and similarly we get third approximation and so on, and we stop the method until beta L curl approximately equal to beta L minus 1 curl up to desired degree of accuracy. And here I mention one thing, that since this again involve this part also, beta involved in this part, so when you use beta naught curl for first approximation, then you should use beta naught curl for this part also, and for when you use first approximation to get second approximation, then you also use beta 1 curl here also. So similarly, proceeding in this way, we get third approximation, fourth approximation, fifth approximation, and so on, and we stop the process until beta L curl approximately equal to beta L minus 1 curl up to desired degree of accuracy. So this is our maximum likelihood estimation in logistic regression. Please stay with us. We will continue logistic regression in our next session. Thank you.